Alright, so in this STEM problem song walkthrough, we are going to be talking about different type of problem with combinatorics. Let's get started. So, another type of problem, let's get started. At the Yazoo City High School, an organizer for a STEM club needs to split 7 students into a group of 3 and a group of 4. 2 of the students, Benjamin and Jack, never seem to get along. To avoid any arguments, they will need to be placed in separate groups. How many ways can we place our students and split them up in a group of 3 and a group of 4 if Ben and Jack need to be in separate groups? So we have a group of 3 and a group of 4. And Ben and Jack have to be in separate groups. So we can have B, J, and then we can have Jack over here and Ben over here. But what we can't have is B, J, and JB. We can't have that. But these are essentially the same thing because order doesn't matter, so that's not allowed, that's not allowed. But obviously you can play around with all of that. So we have a group of 3. I'm going to just place some dots here. And we're splitting 7 into a group of 3 and a group of 4. And Ben and Jack need to be in separate groups. Now, come up with a strategy to handle this problem. And I have a hint for you. We have a restriction here which doesn't let us place 2 people in the same group. So try dealing with the restriction. So try attacking the problem by looking at the restriction. Alright. So looking at the restriction here, hopefully you've come up with a strategy. But now I'm going to find how many possible ways we can arrange them. Without even caring, I don't care about the restrictions right now. I'm just going to find without restrictions. So if we were to split up 7 students into a group of 3 and a group of 4, it's 2 combinatorics. So I'm going to handle the group of 3 first. I have 7 students, and I'm choosing 3 to be in the group of 3. So this is 7 choose 3 ways to place them in the group of 3. Now we've placed 3 students. We have 7 students total. That means we have 4 students left. And we have 4 remaining slots over here in the group of 4. And we need to choose 4 out of the 4 students. We need to choose all 4 of them to be placed into the group over here. So this is 4 choose 4, which is just 1. So there are 7 choose 3 ways that we can form groups, disregarding any restrictions. Now, what if we picked the group of 4 first? Well, if we pick the group of 4 first, we have 7. We choose 4 people to be in the group of 4. 7 minus 4 is 3. We have 3 people left. The group of 3 is empty, so we choose all 3 of them to be in the group of 3. 3 choose 3 is 1. So in this case, it's 7 choose 4. Well, if you recall, these are equal. 7 choose 3 is the same as 7 choose 4. If you remember from our combinatorial identities, 7 minus 4 is 3. If we take the 7 and we place a 3 below the 7, it's the same thing. So they're the same thing. And to make it easier, I'm just going to write this as 7 choose 3. That's the number of ways we can form groups. But we have a restriction here. And now, how are we going to use the restriction to find what we want? Now, hopefully you've come up with a plan. And in the last video, we did the same thing. And because this is one of my favorite strategies, I use this almost every single problem. So we subtract off everything that goes against our restriction. In this case, placing Benjamin and Jack in the big group or in the small group goes against our restriction. So if we place both Benjamin and Jack into the group of 3, that goes against our restriction. If we place both Benjamin and Jack into the group of 4, that goes against our restriction. So we want to subtract everything that goes against our restriction, because then we are going to find what doesn't go against our restriction. And we're going to start off, we're going to place Benjamin and Jack both into the group of 3 and into the group of 4. So let's start off by placing both Benjamin and Jack into the group of 3 and then counting the number of ways we can place the rest. Fill them up. So group of 3. Well, we have Benjamin and Jack. BJ is over here. And, well, we have 7 choose 3 ways to order the entire thing. We have 7 choose 3 ways. We have 7 people to choose from here. But Benjamin and Jack always go there. That's how we're going to get rid of this restriction in here. We're going to place Benjamin and Jack into the group of 3. Now that they're in the group of 3, there are 5 people left. Now, to fill in the last slot over here, there's 5 choose 1 ways. And 5 choose 1 is just 5. So we have 5 for the group of 3. Now let's go to the group of 4. Benjamin and Jack are in here. So we place Benjamin and Jack. Again, we have 5 people left. And we're going to choose 2 of them to go here. So it's 5 choose 2. Now let's just compute 5 choose 2 real quick. 5 multiplied by 3 over 2 factorial. Right? Or no, this is supposed to be 5 multiplied by 4. 5 multiplied by 4 over 2 factorial. These cancel. You get 10. So group 4, there are 10 ways to exclude Ben and Jack from the group, and group 3, there are 5 ways. Well, in group 4, there are 10 ways to keep Ben and Jack in the same group, in the group of 4, but if they're in the group of 3, there's 5 ways. And now we have 2 cases here. We just add these. 5 plus 10 is 15, and we have 15 cases that we don't want. Now we have 15 cases that we don't want. Let's find out what 7 choose 3. Let's compute this. So 7 times 6 times 5 over a 3 factorial. These cancel. We get 35. So 7 choose 3 is nothing but 35. Now we know, going over here, there are 15 cases that we don't want. Subtract off what we don't want. 35 minus 10 is 25. 25 minus 5 is 20. That's also 35 minus 15. So our answer is 20. And that's how we would go about doing such a problem. We separated 2 cases, we added the cases up, we subtracted whatever thing is that we do not want, and eventually it led us to our answer. So hopefully this video is helpful, and yeah.